What is microcode and what is it used for? Microcode is a basic instruction set used in a complex instruction set computer (CISC). These instructions add a layer of complexity to improve the performance of basic operations. Maurice Wilkes, John Stringer, David Wheeler, and William Renwick helped design and test the first microprogrammed computer in 1957. Microcode shapes computer architecture and allows computers to follow complicated instruction sets that may be otherwise limited by hardware alone. Microprogramming is a popular design for application-specific processors. A central processing unit, CPU, and a graphics processing unit are two of the most common examples in the real world. What is microcode? Complete explanation. The definition of microcode is a basic instruction set used in a complex instruction set computer (CISC). These instructions add a layer of complexity to improve the performance of basic operations. As the lowest specified level that interacts with machine code and source code, microcode performs control-level operations in ways that differ from machine language. When a microprocessor needs to execute machine language instructions, the microcode defines how it should function. It's sometimes stored in read-only memory, ROM, or in erasable programmable read-only memory, EPROM. Because it functions as a transition layer between the circuit level and machine instructions, it allows designers to create machine code instructions without redesigning circuits. The result of this basic firmware on the processor is improved loading and running of software applications. Microcode helps power processors and increases their operational efficiency, although it also increases complexity. When comparing microcode versus assembly language, microcode offers instructions at an even lower level. The definition of microprogramming is the act of writing microcode. The entire microcode for a specific computer is known as the microprogram. Microcode isn't used with reduced instruction set computer (RISC) processors, so those compilers generate more instructions than their CISC counterparts. Microcode, an exact definition. Microcode is a low-level code that defines the functions of a microprocessor during the execution of machine language instruction. One instruction in machine language can usually be translated into several microcode instructions. How does microcode work? Microcode is a crucial part of computer processing. The process starts with the software writing stage. Compilers and assemblers convert source code into machine instructions. From there, the machine instructions are converted at execution time into microinstructions. These cause the transistors in the circuits to open and close, creating unique features of computer architecture. The entire process functions this way in a CISC. RISC computers don't use the same instruction method and therefore do not need microprogramming. How do you create microcode? Microcode is stored internally in the microprogram table. Rows and columns organize the pattern of bits in the table, which are written by a microassembler. Once it's embedded, it typically cannot be altered. These facts make it a type of firmware, which is in between hardware and software. It's also the lowest level of instructions when comparing microcode versus assembly or machine language. Where did microcode originate from? The process of creating microcode, or microprogramming, started in the 1940s. Maurice Wilkes worked to develop the Electronic Delay Storage Automatic Calculator, EDSAC. He soon published a paper describing the facts of his new sequencing of control signals process, called microprogramming. His colleague at Cambridge University, John Stringer, helped improve upon and describe the technique. David Wheeler and William Renwick joined the team. In 1957, they helped design and test the first microprogrammed computer. What are the applications of microcode? The primary benefit of microcode is that it allows machine instructions to be easily translated into microinstructions, which help open and close transistors in a circuit. The result is a flexible solution that is easier to design and send instructions than a hardwired alternative. It shapes computer architecture and allows computers to follow complicated instruction sets that may be otherwise limited by hardware alone. Examples of microcode in the real world. Microprogramming is a popular design for application-specific processors. There are many different types of processors that rely on microcode, such as disk controllers, channel controllers, microcontrollers, and digital signal processors. A central processing unit, CPU, and a graphics processing unit are two of the most common examples in the real world. Central processing units, CPUs. A CPU is often considered the brain of a device. Virtually every technological device uses one, including computers, smartwatches, and even thermostats. A CPU functions alongside hardware as a separate component to the graphics card and information storage. Located on the motherboard, this unit contains billions of transistors on a microscopic level. These minute gates function as on-off switches to help the device with loading and running every program in the system's memory. Graphics Processing Units, GPUs. A GPU also uses microprogramming. These devices are designed for parallel processing and work closely with the CPU. Thanks to these facts, they can help improve loading speeds, create innovative features of computer architecture, and help solve complex computing problems. The result is stunning graphics and smooth videos.